Welcome to Constructions. Today I'm going to go over 4 of the 7 that you need to know. And those are the 4 that we're going to go over today. Copying a segment, I've already touched on that one. So this might look like a little bit of review to you, but I'm going to go over it again. So let's start with copying a segment. Doesn't matter how big your original segment is. So here is my original segment. I'm just making it whatever length I want. Now I want to copy that. That means I want to make another segment that's exactly the same length as that. So the first thing you have to do is pick a random point where your segment's going to start from. So I'm going to start my next segment right there, and it's going to be the exact same length as this one. It doesn't matter if it's going in that direction, it could go in this direction, it could go in any direction off that point. It does not have to be parallel or perpendicular to the original segment. We're just worried about the length. It only has to be the same length. So, like I've mentioned before, you do not take a ruler and measure this original segment and then draw a new one the exact same length, because that would be cheating. Well, it wouldn't really be cheating, but there weren't rulers back when constructions were first being discovered, and this isn't really part of the lesson, but measuring is imperfect with numbers and dash marks, all right? When you get down to like nanoseconds and quantum physics, you'll understand that statement that I just made a little bit better, that trying to measure things, especially when they're super tiny, is imperfect. It's one of the problems with humans trying to understand complicated things, is that the measuring always has some type of error to it. So regardless, I don't want to get too far off topic here. So what we need to do is not worry about exactly with numbers how long that is, but we just need to set our compass to how long that is. So you put the point without the pencil on one end, you put the pencil point on the other end, and you don't have to draw a whole circle. You just have to make a little arc mark, part of the circle. So that arc mark shows me that you've measured this line. So don't forget to make that arc mark, because if you're not making that arc mark, you can't really prove that this new segment is going to be the same length as that one, because you're not showing that you actually measured this one. By putting that arc mark there, you're saying, okay, I measured this segment, I set my compass to that length, and I'm not changing my compass size. So my compass is set to that length, and now I'm just going to slide it down to my point and replicate that arc mark. So now we know that this point is the same distance to that arc mark as the end of our original segment is to that arc mark. And then you just get your straight edge. Well, technically you have to pick a point on this arc. Any point will do, because essentially, remember, that arc is part of a circle, so any point on a circle is a radius. They're all the same distance from the center, from that point. So I'll just pick a point here, and I will connect them with my straight edge, and there you go. You've copied a segment, and it's the exact same length as this one because we used our compass to measure it, not the ruler. And we did not change the size of our compass when we moved it. All right, copying a segment. That is the most basic of the constructions. That's why I start with that one. Let me go to copy an angle now. Copy an angle is a little bit more complicated. Just start with any random angle, and then you start with another point that's going to be the vertex. So this point right here is the vertex of our original angle. This point is going to be the vertex of our new angle, and we want to create an angle that has the same exact amount of degrees as this angle does. And we don't need to know the exact amount of those degrees. We don't have to put a number to it. It just has to be the exact same size. So you can start off with just drawing the bottom side of your angle, and just like copying a segment, it doesn't have to go in any particular direction. And it's actually, we're going to call it a ray, so it doesn't even have to be the same length. Rays go on in one direction forever. We're not worried about the length of this angle of the sides. We're just worried about making the opening, the degrees, the exact same amount, regardless of what number those degrees are. Okay, so here's the basic premise to copying an angle is you want to know from this bottom side how far up is the top side. So you're going to want to take your compass and measure, put the pointy end, not the pencil end, on the bottom side, like this, and then measure, set your compass, okay, it's up that far. So all we have to do is come down here and say, all right, it's up that far, we'll put a point there and we'll connect it. But that's not perfect because we don't know where on this bottom line we set our point. So say we set it here and then we come down and we set it right next to the vertex or closer to the vertex and we draw our new point right there. From here to here might be the same distance as from here to here. In fact, it is because we didn't change our compass. So even though those distances are the same, if we connect our vertex to that point, obviously that is a bigger angle than this one. So we're missing something here. How do we know exactly where to set the point of our compass on this line down here? Well, you have to draw a random arc through your original angle first. So you take your compass, you set it on the vertex, and you just set your pencil somewhere on this angle. It doesn't matter if it's way up here or way down here. You just set it there and you draw an arc right through your original angle, and then you don't change your compass and you come down here and you draw the same size arc. So what we did was essentially just copy a segment. We said this segment right here is the exact same length as this segment right there. So that point right there is the same distance from our vertex as this point is from that vertex. All right, now we can measure how far up is this top side from the bottom side from that point, and when we do that, we put a little arc mark there just to show that we measured it, and we reset our compass. And then we come down here to that point, and we know we're in the exact same spot. And we know that if we go through that intersection right there, that this angle is the exact same size as that angle. So that's the key to that one. You got to make sure that you're measuring the distance between these two sides of the angle from the same point on the bottom side as you are from this bottom side. So to do that, you got to draw that arc first, come down, draw the same arc, and now you know you're starting from here and you're starting from there, and you're good to go. Now you've copied an angle. All right, let's go to bisecting an angle. When I say the word bisect, usually people think cutting a segment in half. Like that would be bisecting this segment. It'd be splitting the segment in half. And that's true. You can bisect a segment. Bisect just means cut something in half. But it doesn't have to be a line or a segment. It can be an angle. So let's say we have a 40-degree angle right here. I can cut that angle in half by drawing another line right here and making two 20-degree angles. Now I've bisected that angle. I've made two 20-degree angles. Both those angles are the exact same size because I split this angle in half. Now I just use those numbers as an example. We're not going to use numbers on this test or on any of these constructions. All we're going to do is split an angle in half. So you start with an angle, and then you start kind of the same way we started copying an angle. You draw a random arc through it. All right, because in the last one we wanted to know exactly where to start on the bottom on our next angle, and it's kind of the same here. We want to know we're going to have to start from the bottom and the top and make sure that our starting points on the bottom and the top are the same distance from the vertex. So I could say, let's start right here on the bottom. How do I know where I'm supposed to start up here? Whatever distance this is, I have to be the exact same distance up here. So to know that the distances are the same, we make both of these radiuses of the same circle by drawing an arc through it. So we draw an arc right through both of these. And now we know that from this point to the vertex and from this point to the vertex are exactly the same because they're radius of the same circle. All right, so both of these points are the same distance from our vertex. All right, so all we have to do is find the point, some point that is exactly in between those. So what we're going to do is draw a circle around both those points. So the only way you can really mess this part up is if you draw teeny tiny circles around these points. So let's say I draw a little tiny circle around this point and then the same size little tiny circle around that point. That doesn't help me because the whole purpose of drawing these circles is to get them to intersect. We want these circles to intersect. So we can't draw teeny tiny circles because then they're not going to intersect. So I'm going to set my compass so that I know my circle is going to be big enough that the two are going to intersect. So I'll make a pretty good sized circle here and draw it out here. So that's my circle going around the bottom point. And I'm not going to draw the whole thing. I'm just worried about bisecting this angle. So I want our circles to intersect somewhere in between the bottom side and the top side of the angle. So if I draw this whole circle, I'm not even going to use any of this down here. So I'm not going to worry about drawing the whole thing. And then I'm going to come up here and draw the same size circle around that point. And then where they intersect is the same distance from each point because this first circle that we drew, that was the radius of it. The second circle that we drew, that was the radius of it. And those two radii are the exact same length because it's the same size circle. So they must be right in between the two sides of the angle. So let me do this again so it's a little less messy. This is what it's going to look like. You have your angle. You draw a random arc through it just so that we know that these 2 points are the same distance from our vertex. We draw the same size circle around these 2 points. Now, the circle that we draw around these points doesn't have to be the same size as the arc we just drew. The only stipulation for this circle that we're about to draw next is that it's not teeny tiny. All right, so I'll just say it's going to be about this big right here. So we'll draw a circle around the bottom point, and then we'll come up here and draw the same size circle around the top point. And where those 2 circles intersect is exactly in between the top and the bottom sides of your angle. So if you take your straight edge and you connect your original vertex to that point, you've just split the angle in half. So that's what bisecting an angle looks like. Okay, last one. Parallel line through a point that's not on the line. So here's our random line, and here's our random point. So what we want to do is draw a line through that point that's exactly parallel to this line. You can't just eyeball it. You can't say, oh, that looks about right, draw a line through there and be done with it, because you might be off by the smallest little fraction that your eye can't detect. So how we're going to do this is we're going to copy an angle, essentially. We're going to use the copy angle method. That's why this is parallel line copy angle method. So I had to teach you how to copy an angle first, which I've already done. And now we're going to use that to draw a parallel line, which may sound confusing, but it makes sense, hopefully, once I explain it. So step one is you just draw a random line at a little bit of an angle through this point, through our given line. Okay? Doesn't have to be like anywhere particular on this line down here. You just don't really want to make it straight up and down. Give it a little bit of an angle. All right. Now what we just did is we created an angle down here, and now we're going to copy that angle from this vertex. And it's going to be right here. And if this angle is the exact same size as that angle, then those two, the bottoms of this new angle and this original angle, the bottom sides of them, will be parallel because they're exact same size angle. That's how it's going to work. So how do we copy an angle up there? Let me go back to where I was. I had my original line, I had a point, I drew what's called a transversal through there. And now I'm going to copy this angle down here to that vertex right there. So we're going to kind of have to work from top to bottom. When we copied an angle before, the first thing we did was we drew an arc through our original angle so that we knew that this point would be the exact same distance away from our new angle. But instead of using the bottom side, we're going to use the top side. So let me back up. The first step is draw an arc through your original angle. It doesn't have to be any specific size as long as it's somewhere in between your vertex and your new point. You don't want to draw it way up here like that. That would be too big. You want it somewhere in this region here. So there's my arc, and then I come up here and I draw the same size arc. So let me extend that. So here's my original arc. Here's my new arc. All right, so now we just have to measure how far down this arc that we just drew is the bottom side of this angle. So we start from this point and we measure down to here, and we say it's that far down, put a little mark there so we know we measured it, and then come up here and measure the same thing. So it's like right around there. Now we know that the bottom side of our original angle is this far down our arc, and we just made that same mark on this arc. So if we connect these 2 points, then we've copied that angle, and we know the bottom sides of our angles are parallel. So this line is parallel to that line. And we just created parallel lines by copying an angle. All right, those are the 4 that I want you to understand how to do today. So to show me that you understand them, your homework is going to be to go to that website, Math Open Ref, that hopefully you all went to over the weekend and played around with, because that's what I wanted you to do on Friday. So you go to mathopenref.com, and I want you to draw the picture. Every time you hit the next button, draw me another picture. So if it's a 5-step construction, you're going to have 5 pictures for that particular construction. So let me just do the first one for you, copying a segment. You're going to have your original segment with some random point not on the segment. So that could be your drawing number 1. And then your drawing number 2 is the second step, which is to measure your original segment. And then drawing number 3, so this would be drawing number 1, this would be drawing number 2. Drawing number 3 is start over, draw your original line, your point, you measured that original line, and now you take your compass and you mark an arc down here, so that's drawing number 3. And then drawing number 4 would be to connect to there. So that was actually 1, 2, 3, 4 steps you got to do to copy a segment. And all you have to do is draw what you see, hit next, draw that, hit next, draw that, hit next, draw that, but start over with each one. All right, so most of them are 4, 5, 6 steps, so it's not a ton of drawing, and you can just draw it like I did. You don't actually have to have a compass and make your drawings perfect and super pretty. If you want to do that, great, but not everybody has a compass, and I'm not requiring that you go buy one, because we have a bunch at the school and you wouldn't normally have to buy one, so it doesn't seem fair to make your parents buy one. And they're tedious and hard to use anyway, so as long as you're drawing it like this, straight lines and arcs, you're good. So that's what I want you to do with the other 3, which is copy an angle, bisect an angle, and parallel line. And you also have to do copy a segment, even though I just did it for you. So 4 problems on your homework. Draw pictures for all 4 of those, which shows to me that you understand the order of the steps.